time for maths, and today is an amalgamation lesson. Because you've been working on your multiplication, you've been working on your division, and now it's time to put those two together to help each other out in one sense. So we're going to start with multiplication. We're going to start with the easier problems. And I'm going to give you this problem, Mr. S. And now we're going to use nice small numbers, but the theory that we're explaining to you can be applied to numbers of any size. So you've been multiplying up to 3-digit numbers and dividing up to 3-digit numbers. We're just going to use 2-digit and 1-digit numbers, but the same theory can be applied. Bear that in mind. Please listen to that notice.
Let me just have a little...
Nice.
Just go and regular feature of our videos. 12 times something equals 72. Well, I know my 12 times tables. I have a count in my 12s until I get to 72. So 12 times 5 is 60, you know that. And then 67. One more lot of 12, so that would be 6 lots of 12.
6 lots of 12. So you know your 12 times table, so you can work that out. But let's say the problem is a little bit bigger.
Right, 4 times 92.
Now, last time you just used your 12 times tables to figure out the missing number, which is okay. But do you know your 4 times tables up to 92?
I don't know, it's 48. But that's pretty much it.
So we said that division and multiplication could help one another. What could you do here, Mr. S, to figure out 4 times something equals 92?
Well, if it's similar to how we did this amalgamation with the addition and subtraction, then I could use the inverse.
You could use the inverse. Because what we want is we want the whole of 92. We want something to equal 92. That's what we'd like.
Yeah. 4
but
lots of something.
We want it to be made up of 4 lots of something. So here's 92. And let's say it's made up of 4 chunks of the same number. So this number is the same as that number, it's the same as that number, it's the same as that number. But we don't know what that is. We've got 4 lots of it, but we don't know what it is. So what could we do here, Mr. S? Looking at this diagram, how could this help us? This is called a bar model, by the way.
Well, we know that 92 is the whole amount, okay? So what we've got to try and do is we've got to break that 92 up into these 4 parts. Now, the only calculation I know to break something up, to share something out, another way of saying that is to divide it. So we can divide that 92 into 1, 2, 3, 4 groups. So I think you could do 92 divided by 4, and that hopefully will give us the answer. But even that is not that easy to do in my head.
It's not that easy to do. This is where we're going to have to use our bus stop method. So let's have 92 in our bus stop, and we divide it by 4. Remember, it's a strange layout. It doesn't like any column method. And we don't start with the ones, we start with the tens. So we go 4 into 9 lots of 10, but we can picture it as 4 into 9. We just use our place value. How many times does 4 go into 9?
Well, it goes into 8 twice, so it must be 2 with 1 left over.
Yeah, it goes into 8 twice. That's as close to 9 as we can get. And you're right, there's 1 left over. So we carry that 1 lot of 10 over to the ones to make that 12. Remember, that is 1 lot of 10 that you are regrouping and carrying over.
And
4 now into 12.
12 would go 3 times.
Because you know 4 times 3 equals 12. So we know that 92 chopped into 4 equal pieces is 23. So we know that this piece is 23, this piece is 23, this piece is 23, this piece is 23, because 4 lots of 23 equals 92. Oh, 4 lots of
23. Got it.
Equals 92. You've used division there to help with a missing number in multiplication. Let's have a look at a division problem then, where multiplication might help out. Now, I've placed one on the board here that Mr. S should be able to do in his head, using still, though, now, the help of multiplication. Now, how is multiplication going to help you here, Mr. S?
Well, I know my whole amount, my total amount is 72. So we have 72 is our whole amount, and this question is asking me basically how many 9s are in 72. 72 divided by what equals 9. So if each of my groups was worth 9, I'd need to know how many groups I had. But that's...
So I can't split this into the groups yet. I just know that one of them is worth 9, but I just don't know how many of them there are.
But I can do that in my head because I know my times table so well. I know that 72 is in the 9 times table. Well, how many 9s does it take? Well, 9 lots of 8 would give you 72. So we know now that we have 8 groups.
And each one is worth 9. So 72 divided into 8 groups equals 9.
Yeah.
Now, that is a nice way of demonstrating how your times table knowledge can help you solve a division problem. But let's say the numbers are bigger. The same concept works.
We have got something divided by 17 equals 3. No, Gordon Bennett. Something divided by 17 equals 3. Well, we're going to have to do that bar model to help me picture this. We've got what don't we know here in this question? Because we like to find out what we know and what we don't know. Well, I think according to
we've
what...
got something chopped into 17 pieces. So I can chop this into 17
Yeah, we've got
pieces.
17 pieces. We know that much. Good luck with that one. This demonstration before. We've got 17 lots of 3. Because that's
so
17...
This one's 3. This one's...
Yeah, we know what the rest of them are. We don't need to...
You get the idea. They're all 3.
So something that's been split into 17 groups equals
so we
3.
don't know this.
We don't know the something.
We don't know a whole.
But I do know how we can work it out. Because we've got 17 lots of 3. And when we say lots of, what's another way of saying lots of?
Multiplication. Now, before we do this, let me just be clear. A bar model like this is not a way of working it out. It's not a calculation method. You shouldn't be there drawing it all out and then trying to work out the answer from this. What a bar model is a way of representing the problem. Here we can see that we've got 17 lots of 3, that we've had something chopped into 17 pieces and each is worth 3. And it helps us come to the understanding we need to do multiplication. Yeah. But we should still use our written methods. So 17 multiplied by 3.
I can't do this one on my head because I don't know the 3 times table up to 17, I must be honest. But we can do this method, can't we, which we've learned together.
Start with our ones. 3 multiplied by 7 is 21. We place the 1 of the 21 here, and the 20 goes into our tens columns as 2 lots of 10. 3 multiplied by our 1 lot of 10.
Oh, 3.
3 lots of 10. Add the 2 lots of 10.
5 lots of 10.
5 lots of 10, which goes into the tens column. So it therefore is a 50. 51. 51 divided by 17 equals 3. So there we've used an inverse, we've used multiplication to figure out the division. But, big warning, like subtraction, sometimes if we're missing a number from division problems, we don't do the inverse. We've shown you now different ways of doing the inverse, but it's not always the case. Let's have a look at one more where you don't do the inverse. Now, you might rush into this one and go, oh, it's division, we're missing a number, we've got 64 divided by something equals 4, let's just do the inverse, 64 times by 4. Well, that would equal 256. Now, I'm pretty sure 64 chopped into 256 pieces would not give me 4. If I shared out 64 between 256 people...
They'd all get less than 1 for sure, because that's, you know what I mean?
So, we can't be doing multiplication here. Because in this division problem, actually, we won't need to do the inverse at all. We'll just need to understand that we actually need to carry on doing division. Because we've got 64. And we've chopped it into some pieces, but we don't know how many pieces. But what we do know is each piece is worth 4. Each piece of that is worth 4. Now what we can do here is we just do 64 divided by 4. How many groups of 4 go into 64 is another way of saying division, because division is sharing or grouping. Yeah. And we will get our answer. We will check it. So let's do 64 divided by 4. Start with the tens. How many 4s go into 6 lots of 10?
1.
1.
With 2 left over.
With 2 left over. Your remainder should never be larger than the number you're divided by. If it is, then there's definitely another one you can get there. 4 into 24.
6.
6. So, 64 divided by 4 is 16. Well, that would mean we need 16 equal pieces. Each one is worth 4. Well, 4 times 16 equals 64. So 64 divided by 16 equals 4. So, go and have a go at the inverse problems below. If there's a missing number, 75% of the time you will have to do the inverse. But check those cheeky division ones. When you don't do the inverse, you do another division. If you end up with a larger number here, and you'll think about the question, 64 chopped into 256 wouldn't equal 4. Check your answers. Off you go.